All right, good. All that works. We're good. Okay. Hey, everybody. My name is Andrew Seigner. You can call me Siggy.
Hi, Siggy.
Hi. I work on Linkerd. I also work right here. Thanks, all, for coming into our office. It's great to see folks. You can hit me up anytime on GitHub or Twitter. And, of course, lots of questions as we go along. So William stole like the first third of my talk, so I'll just glaze over what Linkerd is because you've all learned about it. But I think you heard the buzzwords, control plane and data plane. We're going to get into kind of like concretely what those look like and how you interact with them. The control plane's like the administrative side where you interact with it, and the data plane's like the hot path on where all of your data is flowing through. History, you already learned this. It was born out of Twitter, where breaking up probably the world's largest Rails app into a bunch of little microservices in 2010-ish involved kind of rebuilding the same functionality over and over again around reliability and observability and all of that. That was kind of the beginnings of what we call service mesh today. Back then, it was just a library that was written in Scala. And Linkerd 1 took that library and wrapped it up and gave it to allowed everybody else to use it that wasn't writing in Scala. Linkerd 1 had great adoption. You're going to hear good stories from Strava in a minute. There was a class of users that had more specific requirements. One, they were in Kubernetes. They kind of wanted observability to be like built right in, like out of the box. Linkerd 1 had some good reference designs, but we found that we wanted folks wanted like it to just work. And so we packaged Prometheus into Linkerd 2 as kind of like a first-class citizen. We decided to build the control plane in Go because we knew that we'd be interfacing with Kubernetes. It seemed like a natural choice. It's proved out quite well. Actually, my coworker Kevin is going to give a talk at KubeCon this year about spelunking through the Kubernetes code base, which we end up doing quite a bit here at Buoyant. And for the data plane, we knew we wanted like native performance. We wanted like an order of magnitude improvement in memory, but we wanted memory safety as well. So Rust seemed to kind of fit the bill. We were lucky enough to have hired some folks from the Rust community that work on things like the networking libraries and futures and all of that. So we've kind of put together a team that's building the whole stack. That's been helpful. So quick overview of what Linkerd 2 looks like. As I said, we've got a control plane and a data plane. This is just, if you look at the blue lines, that's kind of where service discovery information lives. So your application says, I want to talk to the user service. It kind of blindly sends off a request. The proxy is getting its service discovery information from our control plane. Our control plane's getting it from the Kubernetes API. There's levels of caching going on kind of at all layers. So even if the control plane went away, the proxy would continue to work, assuming that nothing gets redeployed or anything moves around. And then the orange arrows are kind of layering on the observability. So when you deploy a Linkerd control plane, Prometheus is pre-configured to talk to Kubernetes, find out where every Linkerd proxy is running in your cluster, and it'll go around to each proxy, collect metrics, and then the control plane can get an aggregated view of all of those metrics by talking to Prometheus. And kind of the user-facing ways that you get at that information, we also package in a Grafana as kind of like a first-class component of the control plane. So that lets you really dig into all the different slices of data, and we'll play with that in a minute. And then on the control plane side, we provide a CLI for kind of installation and more administrative work, also observability, and a dashboard that kind of shows our best version of all of this data. The Grafana provides a really broad selection of stuff, but the dashboard is here's what we think is most important to see, and we'll see that in a moment as well. Okay, so the rest of the talk, I'm going to try a demo. I'm going to deploy a whole bunch of stuff, so I'm just going to spoil the whole demo right now and tell you what we're doing. So first I'm going to install a sample app. It's called Emoji Voto. It lets you vote on your favorite emoji. It's really important. And then we're going to inject Linkerd into it, and you kind of heard William touch on that. As far as like not having to change your app at all, we're going to leave this app running, and we're just going to inject Linkerd into it. Usually that would be the whole talk, because there's like a lot of features to talk about. But we wanted to kind of look at what would it look like across a bunch of clusters. So then we're going to take that setup and we're going to deploy it across 4 different cloud providers: Microsoft, DigitalOcean, Amazon, and Google. And then we're going to roll that up into a Thanos instance, which I've just learned about in like the last week or so. And then we're going to use Grafana to look at all the metrics there. I should have asked this at the beginning of the talk, but I can ask it now as we go through, just to kind of level set the demo. Raise your hand if you've used Linkerd before. Woo! All right, cool. Raise your hand if you've used Kubernetes. Okay. How about Prometheus? Okay. Thanos. Yeah, okay, couple. Right.
Only half the room.
Yeah, right. Okay, so now you're going to watch me type a bunch of commands. We'll see what happens. So the first thing I'm going to do is just deploy our sample app. Let me hide that. Can you all see this okay? People in the back, I can make it a little bigger.
Oh, it switched. But yeah.
Sorry. Oh, thanks.
A little bigger.
A little bigger? Okay, let's do that. Here. So okay, so this is just our sample application that I mentioned. We're just going to pipe that into Kubernetes. And if this all worked, let me make sure I'm on the right Kubernetes cluster. I'm going to be bouncing between 4 different clusters, so hopefully I'm deploying the right things on the right clusters. Yeah, what can go wrong? So I just want to pop open the sample app just to confirm that it's running. Service, web, service, 80. Okay, so if everything works right. Okay, so we have a sample app. You can vote on your favorite emoji. You can view a leaderboard. You can see there's already some stats on like which emojis are getting voted on the most. It's because we have like a load generator in the back that's just like randomly voting on things.
It seems to like donuts. It's very biased.
It's very biased towards donuts. That is a very good observation. Yep. Also, what doesn't show up on the leaderboard is this first emoji, and that's because when you click on it, you get an error. That is intentional. So we're going to kind of dig into like, this is kind of a typical situation. Like I have my app, a button doesn't work on the website. Like, what do I do? So the next step is to install Linkerd while this is all running. So let me make sure nothing is up my sleeve, nothing's deployed already. So I already have a Linkerd CLI set up, which has a whole bunch of commands that you can run, nice tab completion, that allows us to install it. So I'm just going to take the install script and pipe it right into kubectl. And now I'm installing the control plane. We haven't touched the application yet. We've just installed a control plane that kind of gives us the administrative view. And just to kind of back up, what I did was I typed a Linkerd install command. All that's doing is outputting a big blob of JSON, which like you're totally free to just like take and edit it and whatever. This is kind of our default install, but we try to be really explicit about like this is exactly what you're installing onto your cluster. So all I did was pipe that right into kubectl. So if everything worked right, I should be able to run we have a check command that confirms that everything's come up correctly. I'll just kind of talk awkwardly a minute while the rest of the control plane comes up. And I can vote on some more emojis. Maybe we can find that donut. Let's see how that's doing. It's up to 26. It's very popular. Okay, let me take a look. Okay, so everything's up and running. So the next step is I'm going to take that same sample app and I'm going to leave it running. I'm going to leave this, like the port forward open. It's still there, but I'm going to redeploy it with Linkerd injected into it. So that looks like that same command. Pipe it into Linkerd inject. Oops, need a YAML on there. And then put that back into kubectl. So let me unpack what I just did there. So I curled the same application YAML, that's just our application as is, and then I piped it into a linkerd inject command. All this does is take that YAML and insert a bunch of linkerd proxies into one linkerd proxy into each deployment. And then again, just like our install command, we just hand you back the YAML. You can kind of look at it, make sure you're comfortable with everything that it's doing, and when you're happy with it, you can pipe that right into kubectl. So, in this other terminal, I've had this port forward going. If it all worked, I should just be able to like refresh this page. This is now like part of the service mesh. Linkerd is handling all of the connections. Let's see. Yes. Okay. I swear I didn't break it. It's probably. I'm going to blame my laptop. Give me a moment.
The port forward picks a pod, so you have to restart it.
There we go. Thank you. It's funny. I can't even. It's my browser's like screwed up. It's not letting me click on anything. But that was the leaderboard. That was on the leaderboard. Thank you. User error. Okay. All is well. So anyways, everything's still up and running. So let's kind of dig into like what's going on. What do we know? So now that we've injected our application, we should start getting some information about it. So from like a really coarse view, I can say, give me like basic request level information about everything that's in the cluster. And you can see there's really two namespaces we care about. There's a linkerd namespace, because we use linkerd proxy in the linkerd control plane. We're kind of like eating our own dog food, like we use linkerd to power linkerd. And then because we've just done the injection into the Emoji Voto app, we've already got success rate, request rate, and latency for the sample app. I'm going to keep harping on that point. Like, again, we haven't changed a single thing in our app, and we've got these like pretty rich metrics around it. So let's kind of dig in to some of the features in the UI to let us kind of dig into like where things are broken, what's going on. So you can see here, this is like kind of a similar view of the stats I was just looking at, where we're listing all of the different deployments. And you can see that one deployment is at 100%, one's at like 80%, one's at 90%. It's like something's clearly broken, but typical microservice architecture, it's hard to know like where the failure is. So let's start at the web service. And you don't need to like see all of these details about what's going on the screen, but just kind of get a feel for like the different parts. This is a little topology of kind of what's calling what. You can see we've got a load generator calling a web front end, which is then calling two backend services. And we can see that like the load generator and the front end are experiencing errors. And if we look on the back end, one service is running at 100% and the other is running at 80%. So already we're kind of zeroing in on like that is the edge where something weird is going on. So if we click on the backend service that seems to be behaving badly, we can immediately get a live stream view of all of the requests flowing through it. And we'll see right away that if we sort by success rate, we can see that one of the endpoints out of all of them is at 0%. And if we want to go a little bit farther, we have functionality that lets you really drill into like specific requests at a time and say like, show me like everything we know about this request. We're working on adding more features to this now, so pretty soon you'll be able to look at like the body of the request and all of that. Of course, based on whatever your security model is. But this kind of gives you like a very quick view of what's broken. So by just running this one inject command, we've been able to like see success rate across all of our microservices, zero in on which edge in our topology is broken, and then zero in on like exactly which requests are failing. So if we want to get a little bit more like granular about all of the metrics we're looking at, I mentioned at the beginning, we also bundle a Grafana into this. And so this allows you to really like dig into the metrics and kind of slice and dice it however you want. If you use Grafana and Prometheus, like you're totally familiar with this. You can browse the data by namespace, by deployment. If you have daemon sets, if you want to slice things by job or pod or service or whatever. We even have a top line view that kind of shows like the global request rate across your cluster. It gives you kind of a lot of flexibility to play with it. So now that we've done that, let's replicate that across a few different clusters and see if we can kind of aggregate it up. So I'm going to close these. So just kind of a little housekeeping on what's going to happen is I've like set all these environment variables in my terminal that points to a bunch of Kubernetes context. So I'm going to run a few commands right now that are just going to loop over like 4 different Kubernetes contexts and like run the same thing over and over again. But it's no different than what you just saw me do with that demo as far as deploying a sample app, deploying a Linkerd control plane, all of that. So let's see. First, okay, so I'm going to take, I should call out, so I'm about to install 4 Linkerds across 4 different clusters. I've made a slight modification to these Linkerds to enable them to integrate with Thanos. All of this stuff is like available in our examples repo. I'll give you a link at the end. But I had to make like 4 very small changes, and really what it was around was adding a little sidecar into each Linkerd control plane that knows how to provide data to Thanos. You put Thanos sidecar directly next to the Prometheus container, and it shares the same volume, and it hangs on to longer-term storage. So you give it, you say, here's a Prometheus, here's like your object store. If you're in like, if you're in Google, you give it Google's credentials or whatever, and it starts storing things for the long term. Because kind of the goal with Thanos is you should be able to not just aggregate across clusters, but should be able to get like a longer-term view. I should have called out, maybe William said this earlier, the Prometheus that comes in Linkerd only gives you 6 hours. That's very deliberate. We really want to give you like an up-to-the-minute view of what's going on in your cluster. The idea being that like all of y'all probably have like different observability stacks on how you measure things and how you store things, and we kind of leave that as an exercise to the reader. But long-term storage is definitely a thing, and also across cluster is a thing. Maybe you have a production environment, a staging environment. Maybe for compliance reasons, you need to be like running clusters in different regions or something like that, or for performance or reliability or whatever. So Linkerd is really good at running in one cluster, but again, it's kind of on you to figure out like how do you synthesize like running in multiple clusters. So what I just did was deploy 4 Linkerds to 4 different clusters, and I can confirm that they're all up. I'm just going to like loop over each one and run like a quick Linkerd version command and confirm that like they're all available now in those 4 clusters. The next thing I'm going to do is run that same like get sample app, inject sample app, apply to Kubernetes, and I'm going to do that across 4 different clusters. So same pattern that you just saw me do, but we're doing it across the different cloud providers. Okay. So kind of the last thing to deploy is the Thanos query. So right now we have 4 Linkerds with 4 sample apps all running in one cloud provider. Now we're going to install a Thanos query it's stateless, but it knows how to go out and query data from each Linkerd with its Thanos sidecar sitting in it. Now I'm going to open, assuming that it all came up and the Thanos query is serving a dashboard, I should be able to crack this open. Yep, and yes, all of our endpoints are there. So if you've used Prometheus, this probably looks super familiar. Thanos's UI is like almost exactly like Prometheus's, but with things that are a little bit more specific to it. Namely this page, which shows our different like sidecars and backend data stores. So the sidecars are the things that give like up to the minute information, and the store processes are the ones that are reading from those long-term object stores. And I don't expect you to read this, but each Linkerd control plane was slightly unique, and then I put a little label on it in Prometheus that said like which cluster it belongs to. And that'll let us differentiate when we're aggregating the data where things are coming from. So kind of the last piece is when I deployed that Thanos query, it also included a Grafana instance. And I just took the Grafana that gets packaged with Linkerd, so it's exactly that same Docker image and set of dashboards that that you saw a moment ago. Let's try that again. Okay, cool. So this looks exactly the same. The difference is that this Grafana is configured to talk to Thanos instead of Prometheus. Again, because Thanos and Prometheus look so similar, like Grafana doesn't know the difference. You just tell it, here's a Prometheus when it's really talking to a Thanos. You can see it's kind of interesting. There's already some traffic spikes. That's because I'm looking at a dashboard that's pulling a bunch of metrics from all the clusters, and that causes a traffic spike. So where it gets interesting is that like right now I'm just looking at kind of data broken down in my namespace, which is pretty typical when you're looking at a single Linkerd like in Kubernetes cluster. But what I can add here, and I don't expect you all to read this, but I'm going to add a slight tweak to the query to say like I break things down by cluster, which is that special label that I put on, and I'll make it really big. Maybe you'll be able to read it. What shows up is that now I have exactly the same data, like slice and dice all the same ways, except it's across different cloud providers. So you'll see AKS, DigitalOcean, Google, and Amazon. So all of those same views of deployments and services and latencies and all of that, we've gotten that for free across a bunch of clusters in a totally uniform way. Oh yeah, and one more thing. Because it's Thanos, and because it supports long-term storage, I had a version of this demo running like a few days ago, and just to kind of prove it all works. We're looking at 2 days of data now. I think I booted it like 3 days ago. So probably get like 3.5 or so days. But now you've got like, you know, persistent storage for theoretically as long as you want. So that's kind of the demo. So again, to just really quickly summarize, like, the Linkerd install setup, it's not more than running a Linkerd install command, piping it into kubectl, running a Linkerd inject command into your application, piping that into kubectl, and then use Linkerd stat, use Linkerd dashboard to like immediately get rich metrics about your cluster. William told you about all that stuff. Please come say hi in Slack. We're happy to talk with people and all that. If you want to check out all of the configs that I just used for this demo, go to bit.ly Linkerd-Thanos or just ping me online. Thanks a lot. I think we've got like 15 minutes. I'm also happy to answer whatever questions you folks have.
Do some Q&A.
Okay, let's do some Q&A.
No more pizza or beer until 3 questions have been asked and answered.
Oh God, Mason.
Okay, so just double checking. The Linkerd inject, that's adding an instance into every pod in every deployment?
Correct.
And doing IP tables magic to ensure that everything routes through that.
That's right. Yeah, so, and you're right, there's a subtlety there around, we inject 2 containers, one called Linkerd init, and that does the initial IP tables modification, and then that quits, and then your Linkerd proxy and your application come up next to each other.
You have Thanos store running in each of the clusters?
So we have, it's 2 Thanos processes in each cluster. It's a Thanos sidecar, which the sidecar's job is to read data from the Prometheus's like short term and write it into the object store. And then there's a Thanos store, and its job is to read from the object store. And both of those look the same to the Thanos querier, which is outside of all of them. So the Thanos querier is querying a sidecar and a store. It's the same API. So Thanos thinks it's talking to 8 things. Yeah.
So the Linkerd E2 proxy, does that do protocol translation? So could it do like HTTP 2 to HTTP 1.1?
Yeah, so I believe we have functionality now that will do upgrades from H1 to H2. If you're doing an HTTP 1 request, I think we do that automatically today. Like if it's between 2 Linkerd proxies, it'll be H2.
Okay.
And
can I do a follow-up question?
Yeah, sure.
If I wanted to extend Linkerd E2 proxy to add another protocol that it supports, is that something that would be, oh sure, we have extensibility points for that, or is that sort of a bigger project?
I mean, it's all open source, so it's all possible. I don't know if we have like a plugin interface yet, but the folks that are responsible for those Rust libraries,
yeah.
So that code may not even all live in the Linkerd proxy itself. It may live in the Rust networking libraries that we depend on, but they're also written by people that work here.
Sure.
And so they're very amenable to working with folks. So if there's a particular protocol you're interested in, like I'd open an issue and just like get folks talking.
Sure.
Yeah.
On the slide.
Awesome.
Thanks.
When are you going to have the plugin architecture?
Sorry, say that again?
When are you going to have the plugin architecture? So we actually write some filter and things on top of that.
Sorry, I missed that.
When are we going to have plugins?
Oh, plugin architecture.
Yeah, for 2.
I see. Yeah, Linkerd 1 was really awesome about that, wasn't it?
Yes.
Yeah.
I write a lot of those.
Yeah. It all depends on. I'm going to give like a wishy-washy answer. It all depends on like how much the community wants a particular feature. So if there's certain like environments, we touched on, we only run in Kubernetes right now in Linkerd 2, but like, eventually we may want to support more. If there's enough desire from the community for that, like, anything's possible. So similar answer, like probably open an issue and see how much attention it gets.
With 1.x, we were lucky. We were on the JVM, which made it really easy.
Yes.
There's not really an equivalent for that in Rust.
Yeah, exactly.
So, yeah, it's a little more complicated.
Basically another question for that is, what is the alternative for DTAP?
For DTAP, great question.
Okay, we don't like DTAP.
Yeah, we don't either.
But you have something similar to that, right?
Yeah, we're working right now. So right now we don't have like the dynamic routing support that Linkerd 1 has, but it's on our roadmap probably in the next 1 or 2 major releases. So we're still working through like the product development. I would talk to William and Thomas, who's like a few feet behind you, on like how would you want it to look? If you don't want it to look like DTABs, like what would you want?
Yeah, we're in design phase.
How about this side? Alex.
Which is your favorite cloud provider?
Oh my God. Who here works for a cloud provider? It was a really interesting experience setting up a Kubernetes cluster across 4 cloud providers all at the same time. I was pleasantly surprised how easy the DigitalOcean one was. It was really simple to just get up and running. And I'm a fan of things that are really simple. So that probably is my fave for the moment. I'll just stand here awkwardly for a few more minutes, staring at everyone until someone asks a question.
I don't know much about Linkerd 1 and 2, but then in terms of the feature set, what's the major difference between 1 and 2, and why 2 is being pushed?
Yeah, good question. Generally, Linkerd 1 has far more features. I don't know if we'll ever hit feature parity with Linkerd 1. Part of its success was it worked in any environment. So bare metal, Mesos, Kubernetes, if you're working with Console or Zookeeper, using Thrift as a protocol, like it worked across anything. The trade-off with that was that created a really large configuration surface area. And so it made kind of like maintenance and debugging and support a little more challenging. So Linkerd 2 was very deliberately like targeted at a specific thing. Like you are on Kubernetes and you're going to be using these protocols. Like I said a moment ago, like we'll probably expand that over time, but unless you meet those specific requirements of Linkerd 2, if you need a service mesh right now, Linkerd 1's there, and it's been in production for several years, as you'll hear about. So that's kind of the trade-off. Yeah.
This one more. So you showed a demo of doing sort of a cross-cloud, multi-cloud deployment. Do you know? Do you actually have tons of people using Linkerd in that capacity now? Having sort of worked in this space, multi-cloud is really like a good thing to put in your marketing.
Yeah.
But it's a very difficult thing for big enterprises, for instance, to adopt.
Yeah, I think I personally hear more about running multiple clouds, not necessarily cloud providers. This was as much just kind of interesting for us to see if it would work. Yeah. But I do know that, maybe you have like a production cluster and a staging cluster, things like that. And with Kubernetes having some kind of limit on how far it will scale and for resiliency, I do know that like running multiple Kubernetes is kind of a thing. And we get that question a bit, like because Linkerd installs onto one cluster, it's like, what do I do? We have really good documentation on the website as far as like, how do I get my metrics out of Linkerd and into something else? You can use Prometheus Federation, or there's a number of approaches. And this was kind of one, with us learning about Thanos recently, it was one way for us to try to do this.
Cool. Yeah. Same question, different aspects. Yeah. Federated Kubernetes clusters. Is there a plan for being able to route between members of a federation?
I think, do we call that? Yeah, Thomas, go ahead. Our head of product back there, giving a thumbs up.
Well, there's no my opinion on Kubernetes Federation.
Absolutely.
Instead on cross-cluster communication, and that's definitely on the roadmap for this year.
Why don't we all grab more beverages and snacks, and we'll come back to the talk. And ask me questions in person.